it going, guys? Welcome to the third session of You're Doing It Wrong, the tutorial series where I, Paul Bamson, go over advanced workflow techniques to save you time and energy going forward. What and why? So technology is moving very quickly, and it's very important to stay on top of the technology that we use on a daily basis in order to save time in your workflows. So the goal of this session and all of the sessions in this series is to teach you the skills to work smarter, not harder, and save time so you can get to design. I believe that a designer should be versed in all tools available to him or her, so they are never bottlenecked by the lack of knowledge of any specific tool, so it's very important to be in the know. Session 3 will be on parametric intelligence, working with Grasshopper and Dynamo. The goal of this session is to get you used to code-based modeling using Grasshopper and Rhino and Dynamo for Revit. We'll get good at rapid iteration and form generation and making smarter models using some of the power that comes with sliders, which you'll see in a little bit. So the two main software that we'll use are Grasshopper and Dynamo. These are embedded or work inside of Rhino and Revit respectively. And so we'll see that integration between those four programs really going forward. So let's start with what parametric means. So some of the terms that are compared with parametric are coding, scripting, and algorithms. The definition is a specific set of instructions and procedure defined by a designer utilizing the integration of algorithms in digital modeling, which are called parameters. Parameters adapt model components based on these instructions and the changing relationships between them. These parameters are the rules and structure that allow for streamlining and flexibility in design workflows. What is Grasshopper then? Well, Grasshopper uses what's called node-based logic, which is a graphic representation of lined code. So typical coding takes place using lines. So you're scripting, you're defining, you have hundreds of lines potentially to accomplish a task. That has a very large learning curve. Node-based coding is actually used for designers to bypass that learning curve and get to the power of scripting without learning how to code. The same goes for Dynamo. Dynamo does the same thing, but it actually taps into Revit's ability to use building information modeling, which BIM is short for. And so tapping into families, tapping into data that's stored in your models, and other powerful tools like that. The fundamentals of scripting. If you understand this, you will be able to build your own scripts. All scripting comes in three main steps. The first step is input. It needs to have a source of data. And that's the start of each scripting process. The next step is the command. What is it doing? What are its instructions? What are its parameters? What is the input being acted on? And then number 3 is the output. So what is the result of those procedures, parameters, instructions that have been run? And what really gets powerful with node-based scripting is when the output of one script becomes the input of another set of scripts. And so you can start linking together your various workflows. And so if a script spits out a set of points, that set of points can be used in anything that requires points as an input. And so you can start linking your scripts together. So this is a very simple script that does a very simple operation, and I'll build this in Grasshopper in a little bit just to show you what it means. But a very simple example, this is a move component, right? So if we go through the three main categories in scripting, right? The point is the what. Move is how. Unit Z is which direction. And 10 is by how much. So when you're talking to a computer, you need to detail each step of the series in order for the computer to execute. If you were doing this in Rhino, you would type the move command, you would select the point, you would then move the point a certain area, you would hit enter to confirm it, right? You're doing all of that yourself. But in order to make a computer do it, you have to break down all of those steps and link them together. So in this case, the steps are the point is the input, move is the command, but the command also needs to know what direction and by how much, and so that information is given. And then it spits out an output point, which is the moved point. And we'll get into this a little bit, but there are a plethora of plugins for both Grasshopper and Dynamo that add additional power to what you're doing, additional features and techniques that don't come baked into the software originally. So we'll talk about a little bit of these, and maybe I'll have a Grasshopper session 2 for more of the advanced stuff, but this is more of a primer. So let's get into it. Okay, so I have here a script that's already been worked out just to show you what the Grasshopper interface looks like, and then we'll start building our own step by step. So the Grasshopper interface, in order to launch Grasshopper, what you need to do is type in Grasshopper into the command line and hit enter. That launches Grasshopper. So I have already launched it, so it's ready to go, but yours will show up with a green loading screen. I have a lot of plugins in my Grasshopper setup, almost way too many, so my Grasshopper takes like 30 seconds to open, but yours should open pretty quickly. So the general interface. Grasshopper opens as a separate window that needs Rhino to be open in order to work, right? It is embedded in Rhino. So you open Rhino first, then you open Grasshopper. This window has a series of structures here. So it has the typical file, edit, view, display, solution, help, and MetaHopper, which is a plugin. You have your tool categories here, and all of the plugins that you install also exist in this location as well. I have a lot of them, and I use many of them on my projects. But the main ones that come with everyone's are parameters, maths, plural, sets, vectors, curves, surfaces, meshes, intersect, etc., which come with all of the base commands that you'll be using embedded in them. So when you're building your own scripts, it's important to dig through these lists and see what they do and see what's possible. Because one of the hardest things with scripting is knowing what you can do, not necessarily what you can't do. And so I highly recommend that you dive deep into these. I'm going to show a pretty broad range, but it's up to you when you're building your own scripts to dig deep and find out what's possible. And then you have your drawing area where you're building your actual scripts. And so all of this space here is available to use in terms of creating components. This boundary here is just a visual divider, so anything that I disable, I tend to throw off in that area just so I know that it's not something that I'm using, but any component will work just fine any place in your drafting area. So you've got your save, which you should be clicking often. Grasshopper does have a pretty good autosave feature, so don't worry about potentially losing any data if it crashes before a save, because it'll actually show you when your last autosave was. You'll also see your preview settings to the right here, which will control the quality and what shows each time. If you have multiple scripts open, they'll exist right here, and so you can toggle between different scripts that you've built. Only one set of scripts will work at a time though. So when you switch, the preview you see in Rhino will also switch, and you'll see that in a little bit. Any questions about general interface of Grasshopper? Okay, so I tend to like to dock Grasshopper so it's right next to Rhino so I can see both things on both sides. But one important point about Grasshopper, this interface, is that nothing in Grasshopper that you see in your Rhino space actually exists in Rhino yet. It's all virtual for very good reason. So let's say I create a quick surface here, and I apply it to this command. I'll show you what that means in a second. I can't select any of this material here. It doesn't actually exist. It's showing me a visual of what's going on in here, but until I do what's called a bake, it doesn't exist in Rhino. So let's say I want to actually go ahead and bake one of these components to bring it into Rhino. You select the component which has the data you want to bake. You right-click on that component. You click Bake. You select the layer you want it to go into. I only have 2 layers in this project, but always create a new layer for every bake. It's just good practice to keep things organized. And now this material exists in Rhino. I can select it, and it's separate from Grasshopper now. So I can select that geometry, move it to the side. You can see the original Grasshopper geometry is still there, but you now have an iteration baked out. And so you can imagine making a small change in Grasshopper, baking, moving it to the side, you have iteration 1. Repeat said process, move it to the side, you have iteration 2, et cetera, et cetera. So when your studio professor asks you for 50 iterations, you're done in 10 minutes. Okay. So let's start constructing our own scripts. I'm going to delete all this here and delete these. We're going to start with a point, and we're going to move that point around to do some interesting things. So there are 2 ways to create points in Grasshopper. The first way is to create a point in Rhino and reference it in Grasshopper. So if I grab my point here and I move it to, hang on a second, I'm going to disable these here. I still have a point on. I'll just make a new document. Okay. So I'm going to create a point in Rhino, and I'm going to place it at the origin. So I typed in 0, 0, 0, which is the origin point. So I have my point here in Rhino. In order to reference geometry from Rhino in Grasshopper, you have to create a component and store it in that component. So if you double click in Grasshopper space, it'll allow you to type into it a command. You can also go to the main tab here, which is params. Click on geometry and select point and drag it down. So there's 2 ways. I always prefer typing. It's much faster than hunting for a component. But if you don't know what component you want, then you want to hunt for it. So yours might look different than mine. That's because my display is set differently. So if you click on display, you'll see draw icons, draw fancy wires, which you should always leave on, and draw full names. I actually prefer draw full names and draw icons off when I'm teaching others so they can read the components. For example, if I create move, you'll see here that it says geometry, motion, move, geometry, transform. If I change it to not draw full names, it shortens everything to just a letter, and you have to hover over it in order to read what it is. When you're learning, I always recommend have draw full names on so you can read what the component is, so you can read quickly what the inputs and outputs are. Okay, so we're going to create our point component. We're going to select our geometry in Rhino that we want to reference. We're going to right-click on the component. You'll see 2 options, set 1 point and set multiple points. For obvious reasons, that's what they do. If we only have 1 point, we'll use set 1 point. The component was orange, which means that the component has no data, right? Orange is the default warning color. There are multiple colors per component. The warning in that case was, I have no data. But now it's turned to gray, which means that it does have data and it's happy, it's working. And you can see a little red X appeared where our point is. And that red X moves with our point because it's being referenced in Grasshopper. Now when you click on the component, it turns green, which means it has been selected. This is how you can identify what geometry you're looking at or working on. And if I gave it something that didn't meet the criteria of that component, like for example, if I set one curve to a point component, it won't work. Or if I had a curve component, I set it correctly, and I plugged it into a point component, you can see that that point component turned red, and it's giving me an error message. Data conversion failed from curve to point, because you can't put a curve component into something that's looking for points. That's very important to note. So if a component turns red, it's very unhappy and there's a fatal error that you need to fix. Okay, so our first operation, we're going to move this point. And so we're going to create the move component. Again, the move component is asking for 2 inputs. It's going to run a command, and it's going to spit out 2 outputs. Now, some components have multiple inputs. And in some cases, not every input needs to be defined in order for the component to work properly. And you'll see some examples of that a little bit later. So our input geometry is our point. I'm going to put point into geometry. And geometry is kind of a catch-all input. You can put curves, surfaces, polysurfaces, B-reps, all into geometry, and it will work. If it says point, though, in the input, you can only input points into that component. You'll also see motion. So we know what, we know how, and now we need to tell it by how much. And so we need to give it a direction, and directions are stored in unit X, unit Y, and unit Z. In this case, we're going to move it in the unit Z. And I'm also going to create a number slider. A number slider will allow me to change the parameter of by how much. So there are 2 ways you can create a number slider, either by typing in number slider, or by double-clicking and typing in the number you want. It will automatically default to that number slider, which is slightly faster. When you create the number slider by typing in number slider, it defaults to a number slider that goes from 0 to 1 with 3 decimal places after it, creating what's called a float. A float is a number that has decimal points after it, or decimal values, and an integer is 1, 2, 3, 4, 5 with no decimals. In this case, for what we're doing, it doesn't matter what type you enter in, but in some cases it does matter if you're going into deeper scripting and coding. So to change the min and maximum of a number slider, you double click on the number slider, you'll get the number slider options. You'll see you'll see float point numbers, which is the decimals. So if you want to add more decimals, you can, or put decimals away. N is just integers, so 1, 2, 3, 4, 5, 6. You can't add more digits afterwards if you have N selected. You'll see minimum and maximum. You can put in whatever numbers you want here. So if you want your number slider to go from 5 to 10, you put 5 in your minimum and you put 10 in your maximum. If you want it to go negative, you put in a negative number in the minimum. So let's say negative 10 to a maximum of 10. You'll see the range of numbers, so the total numbers from the minimum to the maximum. And you'll see the numeric values. So you can change the numeric value here of the number slider before you hit OK. So if I wanted 5, I could do that. Hit OK, and now the number slider is placed at 5, but with a range of negative 10 to positive 10. I'm going to plug that into factor and plug unit vector into motion. And if I zoom out here, you'll see that now my point has been moved. Now, one thing that's important to note about Grasshopper is that it doesn't move things and deletes the original. It needs the original in order to work. So instead of actually moving it, it's making a copy. And so you still have your original point, and you also have your moved point. And so those 2 copies can actually go towards new commands. And if you change the number, you'll see that the motion of that point is changing as well. This is what parametric means, is that you give it a set of instructions and you can apply that set of instructions to interesting ways. And so, yes. Yes, so the number here is just a generic number. It uses whatever units your Rhino is set to. So if you click into Rhino and type in units, of course, if you're using Rhino regularly, you know that you have to make sure your units are correct to what you're using. So in this case, this is 10 feet. And also a quick note, you should always have your absolute tolerance at least 0.001. It's always good practice. It tends to solve a lot of issues when you have a higher tolerance. Okay, so we have our moved point and our original point. I'm going to draw a line between them, and that line will be able to change based on where the original points lie. So I'm going to type in line, and before you click, you're going to see multiple lines here. Each one does a different thing. The first line is like the point component over here. It references a line from Rhino. The second one is the one we're going to be using. It's a command that requires a start point and an end point. Those are the two inputs. Both inputs have to be met in order for the component to work. And the last line here is called a line SDL, and S stands for start, D stands for direction, L stands for length. So if you want to create a line but you only have one point, this is what you use. So you give it a start, you give it a direction, so unit Z, unit Y, or unit X, and you give it a number slider, and it creates a line that way. So in this case, we're going to use the geometry from our move component, which stores our point. And it's actually always good practice to create another point component and plug the output into it. The reason for that is now this component, this point now lives in this component here, and I can move it around the interface. And one of the reasons to do that is sometimes you get multiple outputs from a component, and they all live and will be selected if you click on that component. And sometimes you want to grab a specific thing. So it's always good practice that if your output is points, house them in a point component. If it's curves, house them in a curve component, etc. So I'm going to put that in my endpoint, and I'm going to grab my original point and plug that into start. And now my line is generated between those 2 points. And again, that line is referencing the originals, so it will change as my points change. Okay, so that's basics of scripting. We're now going to get into some more advanced stuff. And I'll explain each step of the way what I'm doing so it makes sense. So I'm going to create a spiral stair. And a spiral stair has some interesting parameters that you need to set in order for it to work right and for it to be parametric, which means if you give it a new input, it completely changes. I'm actually going to use this line as the base of my spiral stair. And I'm going to make it much higher. I'm going to make it with a maximum of 50 feet. I'm going to move that point all the way to 50. Just for my sake, I'm going to reference the script that I already built so I make sure I'm doing it all right. And as I'm building this stair, actually, we'll get to that in a second. I actually need to explain a few more things that are really important for understanding what Grasshopper is doing. So I have my line here. I'm actually going to divide that line into several points. And so just like in Rhino, divide curve is what you want to use here. I'm going to plug my line into curve. You'll see that it has a default of 10, so automatically it's been divided into 10 points, but of course I can control the number of points that it gets divided into. In this case, I'm going to use a number slider that goes to 100. I might not need that many. That's a lot of points, so I'll bring it down a little bit. Let's go to 20 actually. I'm going to actually move the line again, but this time in the unit X. So I'm going to type in move, unit X, line into geometry, and let's say 20 feet. And I'm also going to place a divide curve into that component. So what I did to quickly copy it was I selected the component, I started moving it first, and then I clicked Alt. It's in reverse order to every other program. It annoys the pants off of me. I don't know why they did it that way. But in order to copy quickly, move first, then click Alt, and it will make a copy. I'm going to create a component called point list. What this does is it visualizes the points by putting a number on each one, and so you'll see the order of each point. So it requires 2 inputs. Right now it's working, but the number is very small, so I'm going to put a number slider into size so I can control how big that number is visualized. So 2 is a lot, so let's go back down to 1. That should be fine. And so you're seeing everything stacked on top of each other visually. If you don't want that, click on a component you no longer want to see, and right-click in the black area or the center of that component and hit preview, which turns the preview off. And so now you only see the start point and end point, which are still on in terms of preview. So if you want those to go away, select them all, right-click, preview off. I'm going to create a point list for the other points, or for the other points. I'm going to unpreview this guy as well. All right, so I have 20 points. I'm going to create what's called a panel. A panel visualizes or tells you what is inside a component. So if you're wondering what the heck is this spitting out, create a panel by double-clicking, typing in panel. You'll see panel B at the bottom right here. It's the yellow component. Or clicking on the yellow component under params and dragging it in. Mine is white because I customized the color. So if you right-click on the panel and go to color, which is spelled with a U because Grasshopper was written and designed by, you can then change what the default color is and set the default color. I think the yellow is awful, so I changed it, but you can make it whatever you want. I'm going to plug the points component into the panel, and you'll see here that now the panel is telling me that I have 20 points, actually 21 points. It's important to note that all computers count starting at 0. So 0 is always the first item. And so if the numbers in the list go to 20, that means I have 21 points because that's including 0. So there are a few times where that creates issues in our script. You might see one of those times in our tutorial today. But just note that computers always start counting at 0. And I'm also going to plug that same panel into the other points component. And I'm going to show you the difference between different list types and trees. This is very important to understand for making a lot of your Grasshopper scripts. And in order to show you that, I'm going to create a merge component. A merge component takes 2 data sets and merges them into one data set. I'm going to plug both points into merge, so the points from the original divide curves and the points from the second divide curves. Sorry if this is getting messy, we'll clean this up a bit. And I'm going to plug another panel into that merge. Is everyone up to date? Did I lose anyone?
Yeah, you must have remade that second line.
Okay. So the second line was made with a move component. So I created move, I created unit X, and I created a number slider 20, and that moved the line in the X direction by 20 feet. Right. And then I'm also dividing that second line as well, using a divide curve component. So in that merge component, you'll see that both lists have now been combined into one list. And these lists are in what's called a flattened state. So that means that the list is getting treated as one single tree, and when these points get plugged into another component, they'll be treated as one tree, which means the component will run once. Now let's say I had both components, both curves plugged into a single curve component, and this is just a quick example to see. So I'm actually going to reference both of the original curves in that one component and divide it. So you don't have to really follow this. This is just a visual here. So now both components are housed in one line component. I'm going to divide that and show you the difference between tree types. Okay. So can you see how it seems like there's now two sections in that list? That's two different trees coming out of that curve component. And you can see the line is actually different. A dotted line like this represents a data set that has multiple trees coming out of it versus a solid line which only has one tree. And so this means that when I plug this divide curve component into another component, it will run twice. And it will account for the two line data sets differently. So when I, for example, use a move, it'll run the move component 2 times because I'm giving it 2 trees of data versus 1 tree of data. So you can see how 0 to 41 is different than 0 to 20 and 0 to 20. And so to visualize this so you can see it, I'm going to use what's called a list item component. So you can see here each item, right? These are point coordinates, by the way, right? So x, y, and z, that represents a point. All of these points are in a single list, but let's say I wanted the 24th point or the 8th point isolated, right? That's grabbing data out of your list and using it for a different purpose. You use what's called a list item. And list items have 3 inputs: the list that you're referencing, the index, which is the item number, and wrap, which has a specific function which I'll talk about maybe later. But you only really need the first 2 inputs for it to work properly. So my lists are my set of points. I'm going to create a number slider that tops out at 20 because I know I have 20 items in my list. I'm going to plug that into index. And now you'll see that both points, which are the 20th point, have been highlighted. Even though this is one component, I gave it 2 points in the same component, or 2 lines in the same component. It divided both by 20. And now when I call for the 20th point, it selects both of them. Right? So now both of these points have been separated from the list, and I can do different things with these 2 points. But let's say I plug it into the merge component instead, right? So I merged both of those points into a single list. So instead of going 0 to 20 and 0 to 20, it's going 0 to 41. If I plug this guy into the list, you'll see that only the 20th point of this guy was selected. And so I'm going to put a point list on the merge as well so you can see. And I'm going to unpreview the other point lists. So preview off. So you can see that this is counting 0 to 41. And so each point is being counted as an individual. Does that make sense? How that's working? And so that's the difference between what's called a flattened list, where everything gets treated as an individual, so 0 to 41, and a grafted list, which treats each section separately and gives you 0 to 20, for example, and 0 to 20. So this point list is counting from 0 to 41 from a flattened list, and this list is counting from 0 to 20 and 0 to 20 per line. So understanding that is very important when you're making your scripts and manipulating your data, because that's what you're doing here, is you're manipulating data, fundamentally. But Grasshopper visualizes it for you in using the Rhino interface. Okay, so let's say we wanted to do a truss, right? That's something that you'll probably design in your architecture career in school. I'm going to make these 2 lines horizontal instead of vertical. So I'm going to create 2 new lines in Rhino and then reference them in Grasshopper. I'll just copy this one down. Let's say 10 feet. And I'm going to unpreview all of this that I've done up here. So I'm going to select it, right click, preview off. Oh, and this one as well. So I have my two curves here. I'm going to create two curve components and house each curve in each curve component. You can actually rename your components. So if you right click on a component, you'll see the curve is written up here. I'm going to type in top. And I'm going to put the original component name in parentheses. Most people actually rename the whole thing, and then they go back and they forget what type of component it was because all they see is the name. So if you're building a script and you know what it is, it's fine. But I always include the original name of the component in parentheses. We'll call this bottom. And I'm going to set one curve for each one. Set one curve. Set one curve. Again, I'm going to divide point, or divide curve, sorry, into each. I'm going to give it a number slider so I can control the number of divisions, put that into count. Do the same thing here. I'm going to create a point list to visualize the number of points of each point for both the top and bottom. So if I zoom in here, you'll see that each one is now numbered. I'm going to disable the preview for the curve points so I just see the numbers. Next, what I'm going to do is create a line between them. So this line here will connect all the points to their respective cousins at the bottom and top curves. So 0 is connected to 0, 1 is connected to 1, etc., etc. And so I can actually customize the way this works. You can see that both lists have equal amounts of numbers. So if I were to change a list, you can see that the lines connecting the points are shifting. And you can see that multiples are now getting plugged into the smaller list. And so this is a fundamental process or in Grasshopper that you need to understand when dealing with lists. So there are two types of list relationships. There are shorter lists and longer lists. And the third is equal lists, which is typically what you would work in. But if you had a case where one list was longer than the other, you need to understand how Grasshopper deals with those scenarios. So with a longer list, if a list is longer, Grasshopper will take that last point of the shorter list and apply it to the rest of the longer list. So if I create a larger list component or longest list component and a shorter list component, I can visualize what this means. So I'm going to plug in points into list A and points into list B. And I'm going to create a panel so you can see what's going on here. So points from list A, which in this case is the longer list, goes from 0 to 20. So there are 21 points, but 20 divisions. And I'm going to create another panel for the shorter list. As you can see, the longer list is much longer, obviously, than the shorter list. But when we plug these into larger list, you'll see that Grasshopper defaults to the scenario that you see here. It defaults to the longer list. So when I plug list A into the panel, you'll see that it has remained the same. But when I plug list B into the panel, you'll see that it makes the list just as long, but you can see that that last point was copied all the way until it got to 20 to match the two lists. Shorter list is different. So shorter list takes the shorter list and cuts the longer list down to size. So you can see there that that list got shorter and this list remained the same. And so that's what those two are doing, is it's dealing with the relationships between lists that are of different lengths. Now let's say we wanted to draw the line differently. So right now, if we were to make the lists back to equal length, 1 is connecting to 1, 2 is connecting to 2. But I can do a process called shift list, which will shift either the top curve points or the bottom curve points by however many numbers I choose, and that will change how the lines are drawn. So if I use a shift list, it's asking for a list. In this case, I'm going to shift the bottom, and I'm going to create a number slider that goes to 10, and I'm going to set it to 1, right? Plug that into shift. I'm going to plug a point list to visualize it, and hide the original list point list. And so you can see that 0 has now been applied to where the 1 used to be, and so forth and so on. And the 20 actually got wrapped back to here. So if I were to use this shift list to draw the line, instead of having the endpoint be the original points, but now the new shifted points, you'll see that the truss braces have now gone from 0 to 0, 1 to 1, 2 to 2, but that's all been shifted. And you'll see that 20 has wrapped all the way back to the beginning here. And so wrap, what that means when set to true, is it wraps the list back to the beginning. And so we're going to use what's called a Boolean toggle. Boolean toggles are just like how computers think, right? True, false, on, off, 1, 0. It's a binary. And that binary can be used to turn certain parts of components on and off. So I'm going to set this to true and plug this into wrap. And you'll see that nothing changes because the default for wrap, when nothing is plugged into it, is true. So if I hover over wrap, you'll see that one locally defined value, and that value is, in this case, true. So when I plug in a Boolean toggle that's set to true, nothing changes until I change it to false. And you'll see that the wrap is no longer going back to the beginning and is instead connecting to the last point, in which case is creating a shorter list scenario. So let's say you wanted to connect with the original list here. I'm going to turn this back on and turn this off and reconnect and turn the line off here. What if you want to connect 0 to 1 and 1 to 2 and 2 to 3, etc.? So what you would do is use what's called a true-false dispatch to create a pattern that Grasshopper can replicate through the script. So let's go ahead and create that. So I'm going to create a panel, and a shortcut for panel is quotation. And then I'm going to type true, enter, and then add false to that. And I'm going to change the panel to multi-line data. And so you can see that true is 0 and false is 1. And that pattern is going to get repeated. And I'm going to create another for false to true. I'm going to create a component called dispatch. Dispatch takes a list, deploys a pattern to that list, and gives you the true and false or on and off or the difference between the lists after the pattern has been applied to them. So I'm going to plug this into dispatch pattern, and I'm going to grab the second set of curves here, the second set of curve points, And I'm going to put those points in a new list, in a new component, and plug a new point list to it, and hide the original point list. And so you can see that 0, 1, 2, 3, they go every other now. And so if I connect a line to it, and turn the preview on, you'll see that it's shifting down. Now, I want to do the same thing with the other list. So let's do that. Let's create a second set of dispatch. So I'll just copy this here and put false and true. Hide the original and replace the original. That's false, true. This is true, false. True, false. False. True. There we go. So let me move this in the order that it actually is, in terms of top to bottom, to make things less confusing. And I'm going to move these out of the way. And then I'm going to create another dispatch pattern that connects the 0 here to 1 here. So it will be another set of these, but actually probably in reverse. So I want it to be false, true, false, true. Basically the same orientation. Let's go ahead and try that. Let's go ahead and try flipping it. There we go. Okay, so I shifted the wrong list, but now that I've shifted the correct list, we now have the cross bracing going in the opposite direction. And so this is one way out of many, of course, to create a web joist that you can then apply to your wall, ceiling, or top of structure. So I want to talk about some other important factors in Grasshopper that allow for file manipulation. So I'm going to go ahead and preview this off here. And that involves working with extracting data and geometry from existing data and geometry. So I'm going to hide the geometry that's here and create a new rectangle. Hide. So let me go ahead and create a rectangular box. It starts at 0, 0, 0. So I have a box here. The box has 6 sides that I can work with here. Let's say I wanted just this surface though. So in Rhino, you would do an explode and get that surface. In Grasshopper, it's a similar process. So I'm going to use what's called a Brep, and Brep stands for boundary representation. So this is the component that you're going to use again for poly surfaces. So I'm going to use Brep. I'm going to grab my box and apply it to Brep, set one Brep. And then I'm going to use the command called deconstruct brep. Deconstruct brep gives me the resultant faces, edges, and vertices of that brep. And so faces are surfaces. So now I have all 6 surfaces from the box. 0 to 5, that's 6 surfaces. I have the resultant curves from the box. 12 curves. And I have the resultant points from the box. 8 points. And so I can then take these elements and do different things with them. So I could grab a list item, for example, and extract a specific surface. In order to see which one it is, I'm going to hide the preview for these, so I'm only seeing the one that's being selected. So in this case, I need a number slider that goes to 6, right? So 0 to 5 in this case. I'm going to make the maximum of this number slider 5. That way I know that I am selecting one of these surfaces. If you give it a bigger number slider than the actual items, it repeats the list, right? So shorter list, longer list again. And so with the list items selected, I can cycle through and grab a specific surface and do interesting things with them, right? So like, for example, I can use an area component to grab the area of that surface that I've just selected, or the centroid, which is the center point of that surface. And that center point could be used for rotations, for extrusions, for anything that requires a center point or a point for reference to do a certain action, or a plane. That point can now be used for that. So that's just one way you can extract information from a brep that can then be used later on in your script, whether that's taking a surface and dividing it into a different pattern than the other surfaces. So in that case, we could, for example, take it and cut it into panels. So in this case, I'm going to use what's called a divide domain. There we go. This surface is going to get plugged into domain, and I'm going to give the U and V count. And then these segments are then going to get plugged into domain. And so now, isotrim has split this surface into 5 equal segments that I can then extract again with another list item. So if you see here with the panel, I now have 5 distinct surfaces. So I can take a list item with a number slider that tops out at 5, or 4, sorry. Tops out at 4, 0 to 4, 5 numbers. Hide the preview for the other one. And I can select any one of these surfaces to, let's say, make a solid glass, solid, glass, solid pattern. And so this is how you can really start taking the scripting to the next level and save time by automating a lot of these processes that can automatically be applied once a new input is made, right? So if I were to give it a new box, it would automatically create the exact same scenario with the new box, with the new size, just by changing the input. I spent the time to build the infrastructure, and now the infrastructure is being used to my benefit. So set 1 brep, and now the entire script is changed and used on a different set of parameters, or a different input to give me a new set of output results. So get used to the deconstruct commands and the construct commands. You can deconstruct a point, for example, and get its respective x, y, and z values. Or you can construct a point by using X, Y, and Z to construct a point. All right, really quickly, those two commands, construct, point, is asking for an input of X, Y, and Z. These are numbers. It will give you a point. And deconstruct is the exact opposite. So you give it a point, and it will give you the X, Y, and Z. So using these, you can extract information and data from geometry that already exists or you want to exist. So let's go ahead and build our spiral stair. And to do that, we're going to use a starter or reference curve and generate the entire spiral stair from that curve. So what that means is that if I wanted to get a different iteration of a spiral stair, all I have to do is give it a different reference curve, and it will generate the spiral stair automatically based on the parameters that I give it. And so I'm going to use a curve component and actually use the existing line that we built earlier that goes up to 50 feet. So I'm going to grab the line here and plug it into curve, and now this curve lives in this curve component that I can then freely move around. I'm going to get the start and end points of this curve because those start and end points will be the sources of my structure for the spiral stair. And so endpoints here is a component that asks for the input of a curve, so I'll plug curve into here. And you'll see that it gives me the start point and the end point. And based on the orientation of the curve, start might be at the bottom or might be at the top. And so let's see which one it will be. So I'm going to type in circle here. I'm going to use two circles. One circle will be for the interior pole, and the second circle will be for the exterior steps for the pole. So I'm going to go ahead and plug in end into plane here, and actually the end of this curve is at the top. And so I'll go ahead and make the second circle for the spiral stair, both of which are plugged into plane. And I'm going to use a flip curve component, which will flip the orientation of the curve so the end is actually at the bottom, which is the way I like to think about it. So I'm going to go ahead and create a flip curve component. It will flip the direction of the curve. So I'm going to do that in this case. If this was a curve I was referencing from Rhino, I would use the flip command in Rhino to flip the direction of the curve there, and it would automatically reflect in Grasshopper. But since this was a curve generated in Grasshopper, we have to use a flip curve component. So now I've got the start point and the end point, and two circles that exist in the plane of the bottom point. And I'm actually going to make them two different radii. So I'm going to plug in a number slider. Let's say our pole would be, let's say a foot radius for the first. And we'll say, which is the default anyway. And let's say 10 feet for the second. And so this is the structure of our spiral stair. We'll actually make the pole slightly bigger. So there's circle 1 and circle 2. I'm going to divide both circles equally. So I'm going to use a divide curve component and copy it. I'm going to plug circle into curve. And I'm going to plug in one number slider into both counts, so I always know they'll remain the same. That's very important for this to work properly. So let's say 10 divisions. So now I've got my start curve and my end curve have been divided 10 times. I'm actually going to create a surface from my outer curve, and I'm going to trim it by the results that I'll show you in a second. So let's go ahead and create the lines that constitute our spiral stair, and then we'll use those lines to divide a surface into each step. So I'm going to create a line component, wrong line component. Plug points. So there's our spiral stair structure, or lines to define each one. Let me zoom out here, make sure you can see that. So now we have all the curves necessary to split the surface. And so let's create that surface. And to do that, you use what's called a boundary surface component. Boundary surface. Really quickly, I'm going to enable a plugin that I downloaded called Bifocals, which puts the name of the component next to it. Even if you change the name here, it tells you what the component is fundamentally. I should have had that on the whole time. Sorry. Okay, I'm going to plug my outer circle into that. And it's going to create a surface using the boundary of that closed curve, just like planar surface does in Rhino. And now I'm going to split the surface into its respective curves. I'm going to use a surface split component. You usually have to type out the whole thing. It's this guy right here. It's asking for the surface and the curves that are going to split it. So the surface is here, and my curves are here. And now it looks like there are multiple surfaces existing in the same plane, because there are. And so I'm going to hide the original surface because I don't need it anymore. I don't need it visually. It still has to be there for this to work, obviously. And you can see that all of the resultant surfaces now exist here in fragments. Okay, hang on a second. It says one trim surface. We should have multiple trim surfaces. It shouldn't. Oh, right. I didn't give it my surface in the middle. You're right. You also need to give it the interior circle, which is here. So hold shift and plug that as well into curves. And that should, there we go, that should give us some of our surfaces. I'm going to flatten the results here. And I'm going to flatten the curves here as well. So like I said earlier, there we go. Like I said earlier, flatten and graft actually determines the result of some components. So if you have a grafted list and you know it should work logically, but it doesn't, it's probably because you needed to flatten the list and have all your curves be treated as individuals instead of being treated in trees. So let me show you what that means again. So I have multiple curve components plugged into the same one, and so it created a split tree, and it didn't split correctly. So when I right-clicked on curves and I clicked on flatten, it turned that split list of curves into one list of curves, and then actually was able to split the list correctly. Does that make sense? If something doesn't work, try flatten and try graft, and it might work. just like a basis of Grasshopper sometimes. Okay, so we've got now 11 split surfaces, or 11 trim surfaces, and if I plug in a list item into it, just to confirm, I can actually identify my different surfaces. So I'm going to plug in a number slider that tops out at 10. So make sure the maximum is 10, plug it into index, and I can specifically select items in the list. Everybody here? Okay. So I'm going to take that center surface and extrude it up. It will be my pole, which is the structure of the spiral stair. So let me find which one it is in the list. It's number 1. And so this will be my pole surface. The surface now lives here. And so I'll create a surface component just for visual sake. Plug it in here. And then plug in an extrude component, which is just like it sounds. It will extrude an element in a direction. It's asking for a base, which is your geometry. Curves and points work here with this component as well. I'm going to plug this in here. I'm going to create a unit Z component. It's extruding up the default of 1. but I want it to extrude the entire length of the curve. One way to do it would be to use a number slider, but I want this to be parametric. So instead of using a number that I would then have to go back and change myself, I'm actually going to use a number called length, which will give me the number of the length of the curve that I can then plug into unit Z. So my pole will always change based on the length of the reference curve. So let me show you what that means. So list length, list length also does the same thing for a list. So if you plug in list length and you have 50 items in that list, it will give you the number 50, and it will change based on the length of the list. So that's parametric. But we want line or curve length in this case. And it's just called length in this case. It's asking for the curve, and it'll give you the length in number. So I'm going to plug in a panel here so I can see it, and then go all the way back to my reference curve, which is all the way back in the input, grab it, and plug it into curve length, and you'll see that it's giving me 50. And then I can plug that number into factor Z, and now that curve is being extruded by 50. And so if I change that reference curve, which is way up here, it's automatically changing the length of the pole. Okay, so it's getting in cluttered, so I'm going to have to move you out of here.
Couldn't you also link the first slider of the length straight into the length of the extrusion as well?
You can do that as well. It just depends. Both work. There are always multiple ways to do a thing. But let's say the length of the curve isn't being determined by a number slider, but by a different factor. Yeah. You would use list length or curve length in that case. So that's that guy. That guy's done. So I'm going to move it down here. I still have my other segments to worry about, right? The actual steps. So I'm going to use what's called a Cull index. So list index gives you one item or two items if you plug in two numbers. A Cull index removes an item from a list and gives you everything else. So list gives you one, and Cull gives you everything else but the one you say get rid of. So you want the component called Cull, C-U-L-L, index. The list is my original list of divided surfaces. And the index I want to get rid of is my center surface. So I'm going to actually use the same one that's plugged in the list item and plug that into index. And now I have a new list, which is just my steps. So you can see it goes 0 to 9 instead of the original, which went 0 to 10. It got rid of the one I plugged in the index for. And so now I have my steps, and I have my pole. Let's give the steps a depth in extrusion. Let's say 3 inches. So I'm going to create another extrude component. Plug the base of the steps into it. Unit Z. And since my units are in feet, I'm going to use, let's say, 0.25, which is 3 inches. Ha! Math. Plug that into here, and now they're extruded 3 inches. And so now I have 10 steps that have been extruded with the thickness. And now we need to actually get them up into a spiral stair. So I'm actually going to save. Please, everybody, just go ahead and save right now. It's been quite some time. So I'm going to go ahead and click on the save icon. Your Grasshopper files are separate from your Rhino files. So you would save that separately. So I'm just going to call this YDIW session 03 script. Okay. I'm going to divide my curve into the number of divisions necessary for the appropriate amount of steps for the height of the stair. So I'm going to do a little bit of math here in Grasshopper. So we know that the code for step is maximum between the two treads is 7 inches. So I'm going to take the length of my curve, which is 50 feet. I'm going to multiply that by 12 to get inches. And then I'm going to divide that number by 7 to get the number of steps I need for the height of the stair. So I'm going to do a quick conversion here. I'm going to get curve length again. I'm going to plug the curve into it. So just a number slider to visualize this whole process. I'm going to use a multiplication component. I'm going to multiply by 12. And so I could use a number slider, but I want this to remain fixed. I don't want this to ever change because this is 12 feet, right? 12 feet or 12 inches is a foot. So I'm going to use an integer component instead. And I'm going to set the integer to 12 and then rename it to 12. And then I need to set it. So right click, go to set integer and type in 12 and commit changes. And now I have 50 feet in inches, which is 600 inches. I'm then going to divide that number by 7. Division, sorry, not divide. Division. Take the result from A, or take the result, plug it into A, make an integer component, and set that to 7. Change the name to 7. I'm going to start moving a little bit faster here. And so now I have the required number of steps for the height of the curve, and it's parametric, so whatever height of the curve is will automatically tell me the appropriate number of steps. We can't have a 85.7 step, right? So I'm going to round it up to the nearest 1. So in this case, it's going to be 86. So I'm going to use a round component. So it's going to be 86. And that's the number I will plug into a divide curve component. And so the reason, again, I went through all this hullabaloo is to parametricize the height of this stair. So the original curve is my curve, and the number is my count. And so now that curve is divided 86 times, which will give me 86 steps going forward. Okay, so now here comes the hard part. This is the part that adds a little bit of confusion, but shouldn't, once we do it right. So we have our pole here. I'm actually going to group these together. So if you select a set of components and you right-click in space and you click group, it will group your components together so you can move them around together. So it helps you clean things up a bit. So I'm going to name this one. You can change the name of it. So if you click on the group, right-click, you can name them. Stair reference. Because these aren't the final stairs, but they're the reference of them. This is my pole. This is good to go. Also, the extrusion is open in this case. So you can do what's called a cap hole, which is the same as in Rhino. And now it's a closed Brep. And I'll add that to the group as well. So it's there and that's done. And I should probably do the same to the extrusions of my steps, just to ensure that they are also closed. Okay. And we'll group the rest of the stuff later. All right, so I've got my divisions. Now, I've got a situation where I want to apply each step in ascending order to the points I just created. But I have here only 9 steps and I have 86 points. This is a short list, long list scenario that I discussed earlier. So if I use what's called a project component, which will actually move, oh, this is the wrong project. There are multiple projects, so don't just click hurriedly like I did. You want to use project to plane. The divisions of our curve will be the planes that they'll be projected to. So we'll plug geometry into here and our divided points into plane. So you can see the shortest list scenario. It looked right up until the 9th step, and then it just repeated the 9th step the rest of the way. How do we solve this problem? So to solve this problem, we're going to use a repeat data component that's going to repeat 0 to 9 86 times in this case. And so now we'll have it go from 0 to 9 and then do 0 to 9 again, and it'll apply the 9th step to the 10th point and continue all the way up. So we need a repeat data component. Our data is our initial steps here, and the length is 86, so we'll go all the way back here to 86, and we'll plug 86 into length. Now here's one issue that we have to solve really quickly. So when I look at the steps here, right, it counts from 0 to 9, and the repeat data repeats 0 to 9 86 times, or however many the number of steps I have. So if I change it, it'll be a different number. But when I look here, actually, I don't know if that is necessary for the repeat data for length. Do we have to do -1? We shouldn't have to yet. Oh, okay. So we have 86 steps, but this number slider, actually no, I think it's good. Let's go ahead and run it. So this repeat data is now going to be plugged into geometry. And so now our spiral stair is working correctly. What's weird, though, is that it's only moving up the surfaces, which it should be doing the entire extrusion. One sec. Do that in the data. Oh, you are correct. You were right. Yeah, so let's do that. Let's plug in the list of surfaces into data, and then the resultant data into the base of the extrusion, and that should extrude those down by, yep, there we go. Okay. So now we got our steps. And so now we can hide the original surfaces here. So we'll go in to Cull index and hide it. Do the same thing for repeat data. We'll hide it. Do the same thing for project. We'll keep extrusion. Actually, we'll also hide extrusion. And so our final steps are live in the capped holes component. And so we have one step on the ground. That step is extraneous, so we would just call it out of the final list. And so it would start at 1 instead of starting at 0, which is on the ground. But you can see here that the steps have now been projected up, and it looks like we have, oh, okay, so this is what I was thinking about. So we have 2 steps up here, and so the repeat data is 1 too long. So I'm going to right-click on length, go to expression, and type in x minus 1. Or should it have been x plus 1? Probably should have been plus 1. Okay, there we go. And that might have solved the bottom one down here. It didn't. Okay, so we'll just do a call index and call out the first item. and then hide this guy. Okay, so our spiral stair is done. And that spiral stair is completely parametric, so if we change the size of the interior pole, it'll change the size of our steps as well. Automatically. If we change the height, it will change the number of steps, but keep all of the proportions the same, because we set it up to do that. And that's pretty much it for spiral stair and for the short Grasshopper tutorial. Any questions about what we did here? Anything that didn't make sense? Okay, so for those that want to stay, I'm going to spend about 15 minutes on Dynamo and Revit, but for everyone else, you're good to go. Thanks for coming to session 3. Session 4 will be November 15th on rendered realities, so working with V-Ray and a little bit of Unreal Engine, so that's going to be a good one. Hope to see you guys there.
And now, you're doing it right. Be sure to check out the other You're Doing It Wrong sessions. Thanks for watching.